Hello and welcome to Mike's Maths. Thank you so much for joining us today for this free lesson. The purpose really of today's lesson is to give you a feel for my GCSE specimen exam paper lessons. Because the new GCSE 9-1 syllabus is so new, there are no past papers that we can use. So the exam boards have released what they call specimen papers, which are going to help us. Now, they release foundation ones and higher level ones, and a complete set of papers consists of 3 separate papers. So, for example, at foundation level, which is what we're going to be looking at today, we get paper 1F, paper 2F, and paper 3F. Each paper is 1 hour and 30 minutes, and each paper is marked out of 80 marks. So at the end, when you've completed all 3, they would mark them, they would add the 3 scores together, and then give you an overall grade. Now, the paper that I've chosen for this free lesson is an AQA paper. As you can see here, AQA is the exam board, and we've chosen paper 1F, which is the first foundation paper. It's a non-calculator paper. And the objective really is for you to see how I apply points of exam technique to answering the questions that I've chosen for today's lesson. Okay, basically I've chosen 6 questions because I think they'll give you a good feel for how the lessons are delivered and how they can benefit you. So really we're talking about exam technique here. So as we go through the questions, these 6 questions, we're going to be thinking about these 4 points. The first one is read the question carefully. I know that's pretty obvious, but you'll see how I read the questions carefully and how I go back to them and look at each key word and just try and really concentrate on what the question is asking us to do. As part of that, we'll be underlining keywords. I think that's important because it does encourage you to focus on the key words and remember the main points of the question. This third point is an interesting one. It doesn't apply to every single question, but sometimes we need to make the question real. We need to get involved in a question, especially a practical type of question. For example, a question that may be to do with money, and we're going to see an example of that later today. So make the question real where you can, because it will just help you to have a deeper understanding of it. The fourth point here is probably the most important. We need to clearly show our working, and this really is becoming more and more important in the math syllabus these days. What's evident is that we get more marks these days for clear written English. Okay, we need to explain clearly to the examiner how we've gone about our working, and often we need to communicate in proper written English. So these are the 4 points that we'll be sort of trying to bring out during these lessons or during these questions. So let's fast forward to our first question that I've chosen. I've chosen question 3 to begin, and this is an example where we need to read the question carefully. Okay, so let's begin. First of all, it says circle the fraction that is not equivalent to 3/8. Okay, notice what I've underlined there. Circle the fraction, so that's what we're going to have to do. The fraction that is not equivalent to 3/8. Okay, so we've got to be careful. We don't want fractions that are 3/8. We want the fraction that is not. Notice also it says circle the fraction that is not. So we're only going to circle 1. All right. Well, let's start looking at our fractions one at a time. Let's look at 6/16. Can we simplify that? What goes into 6 that also goes into 16? Well, you've probably spotted that 2 goes into both, so we can divide both numbers by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. So that does equal 3/8. So that can't be our right answer. Let's look at 9/24 now. What goes into 9 that goes into 24? Well, 3 goes into both. So divide the 9 by 3 and divide the 24 by 3. That also equals 3/8, so that can't be the right answer. Next one, 12/32. What goes into 12 that goes into 32? Well, this time hopefully we can see that 4 goes into both. 12 divided by 4 is 3. 32 divided by 4 is 8, so that also equals 3/8. Now at this point we're pretty confident that this must be the right answer. There's only one left, so that must be the right answer. That must be not equivalent to 3/8. But just to make sure you haven't made a silly mistake, let's just check. If we simplified 15 over 35, what do we get? Well, you can see hopefully that 5 goes into both. So 15 divided by 5 is 3. 35 divided by 5 is 7. And then, we can see confirmation that that is clearly the correct answer, because that's 3/7 and not 3/8. Okay, so we've circled the correct answer, which is what the question asked us to do, and that's the way we would leave it. So that's question 3 completed. Question 6 I'm going to move on to now. It says here are some numbers. Okay, now here are some numbers. Don't just scoot over them, have a look at them. Okay, 9.6, 12.6, 15.4, 7.6, 12.4, 17.4. What do we notice about these numbers? Well, one thing you might have noticed is that 3 of them, that one, and that one, end in 0.6, and the other 3 end in 0.4, don't they? All right, so that's interesting. We don't know why yet, but the point is that it says here are some numbers, and we've taken the time to take a look. That's good exam technique before we read this bit. Okay, write the numbers in pairs so that the sum of the numbers in each pair is the same. Okay, might need to read that again. Write the numbers in pairs. Okay, that's actually probably why, look, there's a pair goes there, there's a pair goes there, and there's a pair goes there. So that kind of makes sense, the way they've asked us to present the answer. So we're going to write these numbers in pairs so that the sum of the numbers, well, that means adding them together. So the sum of them is the same. All right. Well, we need to start thinking now then, don't we? We know really what we've got to do. We've got to put these 6 numbers in pairs such that the sum of each pair is the same. Well, logically, you wouldn't add the biggest 2 numbers together, would you? But perhaps that actually might give us a clue. Perhaps we would add the biggest number to the smallest number. That might be a good place to start. Which is the smallest number? 7.6. So let's begin with that. Let's write down 17.4, add 7.6 and see what we get. Okay, 4 plus 6 is 10, 0 there, carry 1, got the decimal point. 7 plus 7 is 14, plus an extra 1 is 15, carry 1, so we get 25. Okay, now again an exam technique. We've used 17.4 and we've used 7.6, so cross them out, but just do it with a pencil, okay, because then you could rub it out later if you needed to. We're just crossing them out so that we don't make a silly mistake and use them again. All right, what's the next biggest number? Well, the next biggest number is 15.4, that's that one. What's the next smallest number? That would be 9.6. Let's see what happens when we add those together. And just to fast forward a bit, that also gives you 25. So 15.4 we've used, 9.6 we've used. Now if we're right, the 2 numbers that are left should also add up to 25. And you'll see, if you spend a bit of time on that, that they do. All right, so we know we've got our correct answer now, but make sure that we present it properly. 17.4 goes with 7.6, 15.4 goes with 9.6, and 12.6 goes with 12.4. Okay, so do you see how we did that? We were pretty careful, weren't we? A little bit of thinking, and we've shown our working. All right, it's good that we've shown our working. It's all there for the examiner to see what we've done. Okay, let's move on. The next question I've chosen is question 11. Here it comes. All right, now this is a tricky question, this one. This is probably the first difficult question on the paper. So we really do need to read this question carefully, and this is one where we're going to have to try and make it real as well. It says Ranjit has 6 coins in his pocket. Okay, 6 coins. If he picks 5 of the coins, the most he could pick is £4.60, and the least he could pick is £2.70. How much money does he have altogether? Well, that sounds a bit complicated, doesn't it? So the first thing is deep breath and just probably read it again. Okay, he's got 6 coins in his pocket. If he picks 5, we know that's the most he could have. If he picks 5, we know that that's the least money he could have. Okay, so we've got to start somewhere. Imagine it's us doing it. It's coins, okay? It's coins. So what coins could he have? Well, he could have a £2 coin, £1 coin, 50p, 20p, 10p, 5p, 2p, 1p. Okay, that's starting to make it real because we're starting to think of this as a practical problem, aren't we? Those are the coins that he could have. We know he's got 6 of them. So let's say, okay, he's got coin 1, 2, 3, 4, 5, and 6. Got 6 coins. Let's think about this sentence here. The most he could pick is £4.60 from 5. Okay, he's choosing 5 coins. So let's say he chooses those 5 coins. The most he could pick is £4.60. Well, let's just play around a little bit. Let's say that these are all £1. Okay, and the 5th one would have to be 60p. Well, you can't have a 60p. Well, if you think about it, what this tells us some information straight away, because I've chosen pound coins here, £4 coins. We've realised that the 5th coin, well, it just doesn't work because we can't get to £4.60, which tells us that there must be a £2 coin somewhere, because using just £1 coins doesn't work. So we realise now that at least one of these must be a £2 coin. Okay, so I'm going to say that's a £2 coin. Now, if we look at the next statement, he chooses 5 and the least he could pick is £2.70. Well, that's not likely to include the £2. So let's say these ones would be £2.70. How is he going to get to £2.70 here? Let's have a little bit of a guess. Let's put £1 in there. £1 in there, so that's £2, £2.50. We need another 20p, so let's put 10p there and 10p there. Well, if he chose those 5, that does give £2.70, so we could tick that statement. And if he chose those 5, we already know that that would be £4.60, so we can tick that as well. In fact, if you think about it, we've solved the problem already. That actually works. Okay, that actually works. So you go back to the question now. How much money does he have altogether? Well, we've just got to add these up. So £2, £3, £4, £4.50, £4.60, £4.70. So the final answer is £4.70. Okay. Now, how did we do that? That was not an easy question particularly, but we started by trying to make the question real. We imagined ourselves doing it. We imagined the coins that we could have, and we imagined choosing 5 of them and seeing what we could end up with. So we just kind of got involved in that question, and that led us to the correct answer. Okay, question number 12 now. With question 12, what we're going to see here is that our working is very, very important, showing our working. But let's read it properly. Here are 3 expressions. Okay, there's 1, there's 2, there's 3. So we look at these 3 expressions. We don't just shoot over them. We look at them. This is B divided by A. This is A take away B. And this is AB, which means, of course, A times B. Okay, so we've invested a few seconds just looking at them and we kind of understand them. Now we move on to this bit. Okay, when A is equal to 2, B is equal to -6. Okay, so when A is 2 and B is -6, which expression has the smallest value? Okay, so which of these has the smallest value when A is 2 and B is -6? Okay, I think I understand the question now. And then it says you must show your working. Oh, okay, that's really, really important. Okay, you would definitely underline that, and we'd leave that underlined as well, in fact. So you must show your working. Well, let's begin with the first one, B divided by A. So B divided by A would equal, well, B is -6, so it's -6, and A is 2, so it's -6 divided by 2, which would be -3. Alright, so we've done our first one. Let's look at the next one now. We'll do this one in green. What about A take away B? Alright, A minus B would be, well, A is 2. Take away, what's B? B is minus 6. So you've got 2 take away minus 6. Well, that's the same as 2 plus 6, so that gives you 8. Okay, now we'll look at the third one. We'll do this one in red. AB, of course that means A times B, so it's 2 times negative 6, that's negative 12. Okay, we've shown all our working. Go back to the question, which expression has the smallest value? Well, I'm sure you can see straight away that negative 12 is the smallest value. Which expression gave that? This one. So the correct answer, we just write AB in there. Okay, and you've shown all your working. So that would be a perfect answer. Let's move on. Question 15 is this one here. Now question 15 is another one where we can think about making it real, because this is another practical problem. Okay, let's read the first sentence. Textbooks are stored on 2 shelves, full stop. Now think, okay, textbooks are stored on 2 shelves. In fact, we've got a diagram here, so we can start to picture it. Okay, that's good. Right. I can basically tick that first sentence because I've read it and I've understood it. This bit then, each shelf is 0.72 meters long. Okay. Each textbook is 30 millimeters wide. Now at that point I'm going to stop because I've got meters here and millimeters here. We probably need to have consistent units here. So 0.72 meters, well, that would be 72 centimeters. If I turn that into millimeters, that would be 720 millimeters. That's a good help because we've got 720 millimeters here and 30 millimeters here. So the shelf is 720 millimeters long. Each book is 30 millimeters wide. Now let's start reading this bit. Can 50 textbooks be stored on these shelves? Question. Okay, well, it's going to be a yes or no answer. And then it says, you must show your working. Okay, well, each shelf is 720 millimeters long and each textbook is 30 millimeters wide. So I have to show my working. First thing I'm going to make clear then is 0.72 meters is 720 millimeters. Okay, that shows where I've got that from. And then we're going to have to do 720 divided by 30, aren't we? So let's do this, 720 divided by 30, because this will tell us how many books fit on one shelf. Because the shelf is 720 long and each book is 30 millimeters wide. So, okay, how many times does 30 go into 72? Well, 2 30s are 60. We're trying to get to 72, so that's remainder 12. So now we have to do how many times does 3 go into 120, which is exactly 4. Okay, so 24 books fit on one shelf. I'd better make that clear. So 24 books fit on one shelf. Now we know we've got 2 shelves, so if I times by 2, we know that that's going to be 48. So 48 books fit on 2 shelves. Okay, so we can put the word so in there. Now go back to the question. It says, can 50 be stored? Well, the answer is clearly no, because you can only fit 48. So the answer is no. Make that very clear. Only 48 can fit. All right, so do you see how I've answered that question very clearly, very carefully? We've shown our working. And one of the things we get from this is we do need to be good at long division. It comes up quite often on the non-calculator paper, and it is definitely part of showing your working. So we can see the importance of basic number work here. So that's question 15. What did we do there? We made it real, didn't we? We imagined putting books on a shelf. It's a practical problem, and we were very careful about showing our working clearly. Now, one final question then. That was question 15, by the way, so that was halfway through the paper, just to give you a feel for level of difficulty. We're going to whiz now fast forward to the very final question on the paper, question 30. So this would definitely be a level 5 question. In theory, obviously one of the harder questions on the paper. So we're definitely going to have to read this carefully, aren't we? So let's begin with the first sentence here. ABCH is a square. Well, think about it, find it on our diagram. A, B, C, H is a square. Oh, yes it is. Okay, that's fine, because I've thought about it. I haven't just read it, I've thought about it, so I can tick that. The next bit, HCFG is a rectangle. HCFG is a rectangle. Yes, so it is. Again, I've thought about that now. I've checked it out, and I'm getting confidence in the question already because I'm understanding it. Okay, CDEF is a square. CDEF is a square, so it is. Okay, so I'm completely understanding everything so far. Next bit, they are joined to make an L shape. Well, yes, I can see the L shape in the diagram. So that's nice. We've understood everything to that point. This is also sometimes important information, that the diagram is not drawn accurately. That means we can't measure anything because it's not accurate. So now we can definitely go to the question itself. It says here, show that the total area, hang on, that's important, this is an area question. Show that the total area of the L shape in centimeters squared is that. Alright, so because I've read that carefully, I know this is an area question, and I've got to show that the area is x squared plus 9x plus 27. Well, in a way that's quite good news, because they're telling me that that is the area. It's like telling us that that is the answer. We've just got to show why it's the answer. Okay, well, let's start thinking about this. This is area, okay, the area of the L shape. Well, if we start thinking about this as a practical problem, if you had to work out the area of the L shape, you could work out the area of that square, the area of that rectangle, and the area of that square, and then add them all together. Okay, that's making it a practical problem, isn't it? Work out 3 separate areas, add them all together, and that will give you the total area of the L shape. Okay, so that's the level of thinking we need before we begin. What we've now got to do carefully is show our working for working out the area of each bit. So area 1, okay, well area 1, we know it's a square, and the area of a square is length times width. Well, the length is x plus 3, therefore the width is also x plus 3 because it's a square. So we can say the area is x plus 3 times x plus 3. That's length times width. Now we need to multiply out the brackets here, or expand the brackets it's called, isn't it? So x times x gives me x squared, x times 3 plus 3x, then 3 times x is plus another 3x, and finally 3 times 3 is plus 9. Now we can simplify that. We've got x squared, there's no other x squareds to add that to, but look, we've got 3x plus another 3x. Well, that is the same as 6x, and then we've got the plus 9 at the end. Okay, so we've done area 1, and we would have scored marks already for doing that. Okay, probably 1 mark for that. Area 2 now, so we're concentrating on this. Well, area 2 is a rectangle. That's length times width. To work out the area, the length times width, well, we know that this bit is 3, and we know that the length is x plus 3, don't we? So the area is 3 times x plus 3, that's the length times the width. If we expand the bracket again, 3 times x is 3x, 3 times 3 is plus 9. Okay, keep going. We now want the area 3. So we're concentrating on area 3, we're concentrating on this thing. Well, area 3, it's a square, remember? They've told us it's a square, so if this is 3, then this is 3 as well. The area would just be length times width, which is 3 times 3, which is just 9. So remember, we want the total area, which would be add them all together. So the total area is x squared plus 6x plus 9. That's, just write that out, that was the area of area 1. Then we're going to have to add area 2, which is 3x plus 9. Yeah, that's that bit, remember. And then we have to add area 3, which is that extra 9, so we add 9. Now we simplify it. Well, there's only one lot of x squared, isn't there? There's no more x squareds I can add that to, so we leave it as x squared. Now work out the x's. Well, we've got plus 6x plus another 3x. That would give us plus 9x, wouldn't it? And then if we add the numbers together, you've got plus 9 plus another 9 plus another 9. That's 3 9s, that's plus 27. So we can say that the area is that, and that's exactly what we wanted. There it is, x squared plus 9x plus 27. So you know that that is correct. Okay, you know that's correct because they gave it to you in the question. All right. So how did we do that one? Remember what we did. We read it nice and carefully. We were careful to understand the first 3 sentences here. We looked at the diagram. We took our time. We made it practical by saying, well, if I want the area of the whole L shape, I'd have to add 3 separate areas together. And then we were just careful with the algebra, and we end up with the correct answer. So that brings us to the end of this free lesson. I hope that's given you a feel for how I approach these exam tutoring sort of lessons that we do. We've been thinking about exam technique throughout this paper. So let's just go back to the very beginning. Here we go, the very beginning here, and just recap. Hopefully you've seen the importance of reading the questions carefully. Very important. We've been underlining keywords. That's true. We saw a couple of examples where we were really helped by making the question real. That helps you to get involved in it, think about it as a practical problem. And we've seen also the importance of clearly showing our working. So I hope that's helped you, and if you wanted to take this further, then you'll be able to buy the full lessons by going back to my website. You'll be able to find them all there. Remember, each paper is split into 2 because it takes an awful long time to go through one full exam paper. So each paper is split into 2 sections, a first half and a second half. And I go through every single question on the paper. So if you'd like to check those out, please do. And thank you again for joining us today. So as I say, I hope that's helped you, and I look forward to speaking to you next time on Mike's Maths. So goodbye for now.